So we are getting into logs finally. Okay, so we already know about exponents. If I have something, you don't have to write this down, but if I have something 2 to the 4th power, right, we know this represents 2 times 2 times 2 times 2. So it's whatever the base multiplied by itself by whatever the exponent is. So if the exponent's 5, we're going to multiply 2 5 times. We already know this, which we know this would be 16. All right, but now let's say we're thinking about things the other way around. Let me shut this door. I don't know why we're so rowdy. Okay, so now let's look at things the other way around. So we know if I have a base and I give you an exponent, we can easily simplify that. But now let's say I ask you 2 to what power will give me 16? And now we can solve this in our heads because we know it would be 2 to the 4th, but where the exponent is the unknown, that's where logs comes in. Okay, so where the exponent is unknown, that's where logs comes in. So there's a way to write an exponential, something like this, in log form. So the way we would change 2 to the x power equals 16 and write it as a log, what we're going to do is we're going to have log, and whatever our base is sort of our subscript. So log base 2. And then it's our exponent of x. So this reads log base 2 of x equals, oops, sorry. Our exponent is the other side. Sorry. Log base 2 of 16 equals whatever the exponent is, because that's what we're solving for. So that's x. And what I need you to be able to do is I need you to be able to interchange these two. I need you to be able to go from an equation to log form, exponential to log, and from log to exponential. So let me write it out in words for you. It's log, change the color here, and then here is your base. Next to your base is your answer, equals the exponent. Okay, so let's look at some simple examples. So if I have log base 3 of 81, this is the same as 3 to what power gives us 81? So let's just sort of compare and contrast right here. When I wrote out my log, do I have an equal sign here? Do I have equals x? No, you do not need an equal sign. You do not need to make it an equation. But when we change it to exponential, do we need it to be an equation? Yeah. So when we're writing the log, we do not need that equal sign. It's implied. 3 to what power gives us 81? It is implied here. Okay, so now we have to figure this out. So if we're saying 3 to what power gives us 81, well, we know 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth power is 81, right? So x has to equal 81. So this reads log base 3 of 81 equals 4. That's our exponent. Okay, you all tell me, what is log base 2 of 64? Aditya?
6.
You got it. All right, so how does this read? This is saying 2 to what power gives me 64? X equals 6. All right, what about log base 100 of 1? So what is this asking us? This is asking us 100 to what power gives us 1? 0. Isn't anything raised to the 0 power 1? So what does x have to equal? 0. So log base 100 of 1 is 0. Okay, so now I want to talk about log base e. Is that okay? E's a number, right? So now we have log base e. Instead of writing log base e, because mathematicians just like to make things complicated, we write ln. Anytime you see ln, that is the same as log base e. E's the subscript, yeah. That's your base. So E is a repeating decimal, right? We talked about that last class. It's, what was it, 2.718 something, something, something. So that's E represents, sort of like how pi represents 3.14, E represents that other repeating number. Right, something else we need to know. Whenever you have log without a base written, it is log base 10. So whenever you just have log without a subscript, without that base written, it is log base 10. So log base e is written as just ln, and log represents log base 10. So if you ever see log written without a base, it's immediately log base 10. So if I give you ln of y equals x, ln of y equals x, this is telling us log base e of y equals x, which is e to the x power equals y. Okay, so let's talk about graphing exponential. Let's talk about graphing log equations or log functions. No. Okay, we agree an exponential is y equals b raised to the x power. And I'm going to tell you the inverse of an exponential function is a logarithmic function. Let's talk about why that's the case. Why do we need to bring in logs as the inverse? So right now, let's try to find the inverse of y equals b to the x. If you remember, when we want to find an inverse of a function, what do? We start off by switching x and y, and then what do we solve for? So when we're solving for the inverse, you solve for y. So first step we do is we switch x and y. So we have x is equal to b to the y. And then solve for y. Is there any way right now to solve for this y in terms of x? There's no way to solve this in terms of x. No way to solve for y in terms of x. That's why we need to bring the log into this, because what happens when we have an exponential, I can write any exponential as a log, right? And now there's not really dealing with exponents when we're in the log format. Let me show you what I mean. So if I have y equals b to the x, this is the exponential. We're going to go to the log version of it. So we have our exponential. What would be the log version of y equals b to the x?
Log of b to the x equals y.
Log base b of x equals y. So now let's talk about the inverse now. So now we have our exponential. We changed it to a log. Now let's talk about the inverse. Same idea. What do I do when we want to come up with the inverse? We switch x and y. So now we're going to have log base b of y equals, hold on, we had log, oh, I mixed this up, didn't I? This was log base y. Log base b of y equals x. Sorry, guys. Going too fast here. So now we're going to switch the inverse. We're switching x and y. So now we're going to be log base b of x equals y. Is y now solved for? Yeah, so there's no other manipulation we have to do. This would be our inverse. We're going to do some problems. Yes?
Why can't we swap x and y in the exponential function?
You can, and actually when we get into some complicated graphs, we actually will, and we'll leave it as an exponent and then plug in numbers and try to find it. But when we're writing the equation of its inverse, you have to solve for y. So the only way to solve for y is to then change it into a log. So when we're graphing it, it actually is easier to leave it in an exponential instead of just plug in numbers for it. But when we come up with the equation, the rule is switch x and y, solve for y. You have to be able to solve for y. Okay, I want us to write the inverse of y equals 2 to the x. Okay, so this is our exponential. So our exponential is y equals 2 to the x. Now I want to change it into a log. How are we going to change it into log? It's going to be log base 2 of y equals x. Now let's go to our inverse. What do we do for the inverse? Switch x and y, then solve for y. So now we're going to switch x and y. So log base 2 of x equals y. Then we solve for y. Is y already solved for? Yes. So we've now come up with our inverse. Now let's graph it. So I want us to graph y equals 2 to the x and its inverse. It's more of a sketch. Let's say sketch. It's not going to be completely accurate. Okay, we ready? If we're sketching y equals 2 to the x, that should be fairly simple for us. Why? Because we're not shifting at all, right? So this is an exponential. What is my key point here? Claire, do you have a question? Mm-hmm.
Instead of finding the log of the exponential and then like switching the x and the y, can you switch the x and y first and then find the log of that?
Yes, that's fine. All right, so for y equals 2 to the x, what's our key point?
0, 1.
Good, our key point is 0, 1. Where is there an asymptote?
X-axis.
Good, we have an x-axis. We have a horizontal asymptote 1 unit below the key point, which is the x-axis. So we know we're looking something like this. Do we agree?
Oh, we can just sketch it. We don't need to like actually.
I'm sorry?
Like, can it just be a general sketch?
Well, right now I'm generally sketching it, but just for the purpose of its inverse, what I want to do is I actually want to plot some points. I just wanted to show you what the general sketch looks like, but I do want to plot some points. So if we have y equals 2 to the x, I want us to get some coordinates. So we know the turning point, or the key point I should say, is 0, 1. So let's go a unit above that, to the left of that. So let's say x is negative 1. When x is negative 1, what is y going to be? A half, right? So I'm just getting a little bit more accurate here. So now we're at negative 1 1/2. Now let's go 1 unit to the right of our key point. So let's say x is 1. If x is 1, y is 2. All right, that's good enough. So now we know we look something like this. Tell me, when I just give you coordinates, if I just give you a relation, a relation in sets of points, and I ask you to find the inverse of that set, what do? What do we switch? We switch our x and y. So if these are our points, right, for our exponential, for its inverse, aren't we just switching x and y? So the inverse we're going to have points 1/2, negative 1, 1, 0, and 2, 1. All right, so let's plot those. So now we are at 1/2, negative 1. And then we're at 1, 0. And then we're at 2, 1. Where do you think the asymptote's going to be this time? The y-axis. So it looks something like that.
Where would it be the y-axis?
I'm sorry?
Where would it be the y-axis?
Okay, so if you kept plugging in points, you'd see that it would get closer and closer but never cross it. But let's say We didn't do that. Let's think of the inverse here. So the inverse, what do? We switch x and y, right? So now we're going to have x is equal to 2 to the y. And I know that's not the formal correct inverse because we'd have to solve for y, but this sort of just makes more sense to us than reading it as a log. So now if we're looking at it this way, x equals 2 to the y, is there any way x could ever be 0 here? If this is my equation, can x ever be 0? Is there anything we could plug in for y that will make x 0? No, that's how we know at x equals 0, which is the y-axis, there's going to be an asymptote because there's nothing we could plug in for y that will make x 0, right? And that was another way. Instead of just getting coordinates for our exponential and then just switching the domain and range, you could have gone to this equation, plugged in values for y, and solved for x. Yes, you may. Okay, go back here. What is this a reflection over? It's not the x-axis, it's not the y-axis. It is a reflection over the line y equals x. And that's not a coincidence, that's always. Here's our, all right, it's a reflection over the line y equals x. Okay, so now let's talk about inverses. So some shortcuts for you. So inverse of exponential. So we write the inverse as an exponential as a log, right? But we can always change that log back to an exponential. So when we have b to the y equals x, right? How do I know this is an inverse? Because we've switched x and y, right? This is our parent function. So our key point is not going to be 0, 1 anymore, right? We're inverse now. So it's not 0, 1, it's going to be 1, 0. The asymptote will be 1 unit to the left of the key point. Do you think we can shift an inverse just like we shift an exponential? Yeah, so let's talk about shifting. If I have b raised to the y minus k plus h, this represents our vertical shift, and h represents our horizontal shift. Okay, let's do some problems. Trying to find an inverse problem. Here we go. All right, so the problem I'm doing right now is number 13 from your homework. I want us to, let's see what it asked. I need to see the worksheet. Number 13, okay, we're asking for a bunch of things. So we are going to answer some questions and sketch. Y equals log base 5 of x. What do you think the first thing I'm going to tell you to do if I'm asking you anything about a log equation? Yeah, this doesn't really make much sense to us, especially when we want to sketch. So I'm going to say change it to an exponential. And when we change it to an exponential, we are going to have 5 to the y equals x. This is an inverse. How do I know it's an inverse?
Because it's x equals something.
Good. We know it's an inverse because we've switched x and y. Therefore, inverse. All right, so if 5 raised to the y equals x is our inverse, what was the original? David? 5 to the x equals y. You got it. All right, let's sketch this. All right, since this is an inverse, my key point is not 0, 1. What's my key point this time? 1, 0. And now I'm going to have a vertical asymptote 1 unit to the left of my key point. What's 1 unit to the left of our key point? The y-axis, right? All right, I just want to sketch. So this is all we have to do is have our key point and then know it goes out, something like that. That's all I need for our sketch. But now I'm going to ask some questions. What are these questions that I'm asking? All right, so A was to sketch. B, I want to know, is it increasing or decreasing? So for this, all you want to do is read from left to right. Is it going up or is it going down? From left to right, it's going up. So it is increasing. All right, next question. We want the key point. What is the key point? 1, 0. Next question, I want to find the equation of the asymptote. What's the equation of the asymptote? It's a vertical line right at 0. Equation of a vertical line is that x equals or y equals? Vertical line? X equals. Guys, do you not know the trick? Whether for vertical or horizontal. If you cut the x in half, doesn't it look like a V? So for a vertical line, it's x equals a number. If you have y equals some number, if you flip that y, doesn't it sort of look like an H? That's y equals a number is a horizontal line. So x equals a number is a vertical line, y equals a number is a horizontal line. Why are you all laughing? This is a clutch trick.
That actually makes it very confusing.
Every time I ask you, is it x equals or y equals, you all always say the wrong thing.
Just do the opposite of what's negative.
X equals xv, I don't know. That's weird that you guys don't like this. All right, so the equation of this line is x equals 0.
If you hit the X, you're going down.
All right, I want to now, last is find the domain and range. No.
Can we get our test?
Yeah, you said this time was short because it's like the second day.
Okay, what's the domain?
All real?
The domain is not all real numbers. Why is it not all real numbers?
Oh, wait.
Because there's nothing to the left of 0, right? Aditya?
X is greater than 0?
You got it. X such that x is greater than 0. Is it equal to 0? No, because the asymptote's there, right? It's never going to cross that. All right, let's talk about our range now. What's our range, David? You got it, all reals. There's other ones I want to do with you from your homework.
No, we'll do the homework.
Oh, can we get our test back? Can we take a break?
Yeah, I think
I'm so tired from this.
Um,
I'm gonna go to sleep.
Hold on. I'm just seeing the ones I circled.
Do you wanna? Oh. It's not bad already at scale of 1 to 10.
Oh, look, I could be sneaky.
Oh god.
Please don't.
Y equals 2 raised to the x squared.
Just 2x.
Oh, so for this one, you want to just plug in numbers. You want to just make a chart and plug in some numbers. So let's see. Oh, this is number 9 from homework.
How many questions do you have?
A lot.
What? Can it be done, Mommy?
Yeah.
Yeah. We have a lot of tests tomorrow.
Guys, I gave you a study hall last class.
Yeah, and we didn't have it.
We didn't have the homework assigned, so we couldn't work on it.
Aw, poor you. Okay, so now what we want to do is let's plug in numbers. I'm going to do 0 in the middle. If I plug in 0 for x, 2 to the 0 is 1. So now we are at 0, 1. All right, now let's go to the left of that. So let's plug in -1. When I plug in -1 for x, what do I get? Y is 2. So now we're -1 and 2. Now let's plug in +1. When I plug in +1 for x, what do we get? Y is 2. Isn't that cool? There's our graph.
Are we done now?
Guys, I'm doing your homework for you.
No, but I need to understand the question.
Okay. If you rather do it by yourself, that's fine. I could do that. I anticipate a lot of questions on the homework. Let's leave it like that, okay? Problems we want to go over. So we're going to end here, let you guys try it by yourself, and then thoroughly go over the homework tomorrow. Yes? Sounds like a plan.